Hello and welcome back to my channel. In today's video, we will discuss the most probable questions asked in machine learning interviews. Starting with the basics, what exactly is machine learning? It is a subset of AI that uses algorithms to learn from data patterns instead of following rigid pre-written instructions. There are three main pillars: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we train models using labeled data. Think of it like a student learning with an answer key to predict future results. Unsupervised learning works on unlabeled data. The model acts like an explorer, finding hidden structures or groups on its own. Reinforcement learning is all about trial and error. An agent performs actions and learns to maximize rewards while avoiding penalties. Supervised learning is a technique where a model is trained on labeled data to learn the mapping between inputs and outputs so it can predict results for new data. So basically, you can give input data plus correct outputs. The model learns the relationship between them, then it predicts the outputs for new unseen data. Unsupervised learning is a technique where a model is trained on unlabeled data to discover hidden patterns, relationships, or groupings within the data. In simple words, it is like giving a bunch of data to a model and asking it to find patterns or group similar things on its own without telling it what is right or wrong. For example, it can group customers based on their buying behavior without knowing any predefined categories. Reinforcement learning is a type of machine learning where an agent learns by interacting with an environment and improves based on feedback. In simple words, it is like training a pet. You reward it when it does the right thing and does not reward or sometimes punish it when it does something wrong. Over time, it learns what actions gave the best results. What is a model? It is a mathematical representation of a real-world process trained to recognize patterns and make smart decisions. Overfitting is when a machine learning model learns the training data too well, including noise and unnecessary details, and as a result performs poorly on new data. In simple words, it is like a student who memorizes answers instead of understanding the concept. They do very well in the practice test but struggle when questions are slightly different in the real exam. Underfitting is the opposite. It is when a machine learning model fails to learn the pattern in the data properly, so it performs poorly on both training and new data. In simple words, it is like a student who has not studied enough. They can't even solve basic questions, so they also struggle in the exam. A confusion matrix is a table used to judge a classifier. It breaks down correct and incorrect guesses into four key categories: true positive, true negative, false positive, and false negative. True positive means when the model correctly predicts a positive case as positive. True negative means when the model correctly predicts a negative case as negative. False positive means when the model incorrectly predicts a negative case as positive. False negative means when the model incorrectly predicts a positive case as negative. Cross-validation is a technique where the dataset is split into multiple parts to train and test the model several times, which ensures better evaluation and reduces overfitting. Instead of training and testing the model just once, we split the data into multiple parts, train the model on some parts, and test it on the remaining parts, repeating this process several times. This helps us to get a more reliable and accurate estimate of the model's performance. What is an ROC curve? It is a graph showing how well a classifier performs by plotting the true positive rate against the false positive rate. Precision tells how accurate the positive predictions are. Recalls tells how well the model finds all the positive cases. Precision focus on quality, recall focus on coverage. F1 score is the harmonic mean of precision and recall. It is the go-to metric when you need a perfect balance between the two, especially useful when the class distribution is uneven. Regularization is a technique used to prevent overfitting by adding a penalty to the model for being too complex. In simple words, it tells a model, don't try to fit very small detail in data, keep things simple so you can generalize better. So basically, It reduces model complexity, helps the model perform better on new data, and avoids learning noise from training data. Two primary techniques are L1 and L2. L1, it adds a penalty equal to the absolute values of coefficients, which can shrink some coefficients to zero and effectively perform feature selection. L2, it adds a penalty equal to the square of coefficients, which reduces their values but does not make them exactly zero, helping in better generalization. It is the balance between underfitting and overfitting to achieve optimal model performance. If your model is too simple, it has high bias, and if it is too complex, it has high variance. So we need to balance where the model performs well on both training and new data. Feature engineering is the process of creating and transforming features from raw data to improve the accuracy and performance of a machine learning model. It means preparing and modifying the data in a smart way so that the model can understand patterns better and give more accurate results. Gradient descent is an optimization algorithm used to find the best model parameters by minimizing the error. It is like going downhill step by step to reach the lowest point where the error is minimum. The model keeps adjusting its parameters in the direction that reduces the error. Bagging builds models in parallel and averages them. Boosting builds them one by one with each new model fixing the last one's mistakes. Bagging reduces variance through parallel model averaging, while boosting reduces bias through sequential error correction. A random forest is exactly what it sounds like, an ensemble of many decision trees working together to give you a highly accurate result. It is a machine learning algorithm that uses multiple decision trees and combines their results to make better predictions. Instead of relying on one tree, it creates many trees and takes the majority vote for classification or average for regression, which makes the model more accurate and stable. A neural network is a machine learning model inspired by the human brain that learns patterns using layers of interconnected nodes. It takes input data, processes it through multiple layers, and learns to make predictions by adjusting connections between the neurons. A CNN is a type of neural network specially designed to process image and visual data, or we can say that it is a deep learning model that uses convolutional layers to automatically extract features from images and perform tasks like classification or detection, which means it looks at small parts of the image like edges, shapes, or patterns and gradually combines them to understand the whole image. RNN is a type of neural network designed to work with sequential data like time series or text. It remembers previous information while processing new data so it can understand sequences where order matters. Dropout is a regularization technique used to prevent overfitting in neural networks by randomly turning off some neurons during training. It means the model does not rely too much on any one neuron, so it learns more robust and general patterns. Transfer learning is a technique where a model uses knowledge learned from one task to solve a different but related task. Instead of training a model from scratch, we take a pre-trained model and fine-tune it for our problem, saving time and improving performance. A generative adversarial network is a type of neural network that generates new data by using two models that compete with each other. One model creates fake data and the other model tries to detect whether the data is real or fake. Both keep improving through this competition.